Hello guys, in this video I would like to present 5 questions dealing with algebra of matrices where we can add, subtract, multiply a matrix by a scalar, and then finally multiply 2 matrices if we can. At the end of the video you can find 3 practice questions with answers only. Let me take a moment here to review some rules that are related to the algebra of matrices. As we can see in the first slide here, please, addition or subtraction matrices, we should have the same dimension, m by n. So we cannot add 2 by 2 plus 3 by 3, or 2 by 3 add 3 by 2. They should be the same dimension. Now, the idea in the addition is easy. If we add or subtract, just add the corresponding entries. 5 and 32, you can add them. 37, easy. 10 and minus 17, you can add them. Minus 7, etc. But remember, be careful, please. You cannot multiply matrices the same way. You cannot multiply the same way. Okay, so we have to multiply row by column. I will show you many examples. Second idea here is scalar. You can multiply a scalar, which is a real number. It can be positive, negative, fraction, not zero. Multiply by scalar. So you multiply the matrix by multiplying each entry. Like 3 times minus 5 minus 15, 3 times 0, 0, 3 times 7, 21, etc. Now, to multiply matrices, there is one condition you have to take care of. One condition. You have to check the dimension of the 2 matrices here. So if A has m by n, and dimension of B is n by p, see these numbers here, n and n, they should match. They must match. Same number. If these are the same number, then the product is possible. So we can multiply AB, and the dimension of the AB is m by p. I put it here now in symbols. A times B is AB. If we have A is m by n, n by p. So the answer will be m by p. So what is this n here, the first one? And then I wrote it here in English. Number of columns of the first. See, this is n here. Second n is, it should be equal to number of rows in the second. So please review this before you start multiplying. I will show now a done example here before we start our questions. So we have a 2 by 2, easy, multiply 2 by 2. Remember carefully, we cannot multiply entry by entry here, 2 and 6, 12, that's wrong. See the answer here, 52, the first element. So you have to multiply row 1. See this one here, row 1, column 1. So this is row 1, column 1 becomes A11. You can see it easily, clearly. 2 times 6 minus 4 times minus 10. So 40 and 12 becomes here 52. Same thing for A12. A12 means row 1, column 2, etc. here. A21, row 2, column 1. Then you can multiply. Look at question number 1. It's a medium question. Given the matrices A and B, some numbers are there. And then we said find the matrix D if the D is equal to A squared minus 3B plus 10A times A inverse. Take a few seconds here. Please, you can pause and see what can we do here. What do we have to find? We have matrix A 2 by 2 given. We have matrix B given. What else we need? How do you find 2A squared? Remember, A squared means It's a product, A times A. You cannot square each number here. That's a big mistake in mathematics. You cannot square each number because A squared means A times A. Here multiply by scalar. Do we have to find the inverse of A and then multiply A times A inverse? Ask yourself, please. Do we have to find the inverse of A and then multiply by A? Think, and you can see the answer in a second. Okay. So what I said here, squared means A times A, not squaring each entry. So let me find first A squared. So it's A times A. 2 minus 3, 5, 1, 2 minus 3, 5, 1. See, directly I go row, and column. See, 2 times 2, 4. Minus 3, 5, minus 15. So that's minus 11 there. Then you can continue the same way. Row by column. Row 2, column 1. Row 2, column 2. You get these numbers. Now, no need to find the inverse in this question because A times A inverse, also A inverse times A, if you have another question like that, it is identity 1001. Even if you find A inverse, you can try it if you have time, please. Find A inverse, multiply A times A inverse. You should get 1001. But remember this 10 here, see this 10 is a scalar. So we have to leave this 10. It cannot be deleted. So now we have D, 2A squared minus 3B plus 10I. Let's see the second slide. You can find D, please, and then you can check your answer. Okay. So 2A squared, we found already A squared there, minus 11, minus 9, 15, minus 14. We multiply scalar by 2. We have the B already, we did not touch, multiply by minus 3. See what I did here, minus 3, I included the minus 3 as a scalar, so I changed it to addition. But remember, I put inside minus 3. You can leave this minus if you like, and then enter only 3. You can leave this minus, then you subtract. Plus 10, multiply 10 by the identity 1001 becomes 10, 0, 0, 10. So when you add all these together, you add entry by entry in the same location, you get matrix D, minus 18, minus 33, 39, minus 21. You can check it, please. Let's see question number 2. C is 3 minus 1, 2, 3. And D, 4, 1, row 1, 2 minus 3. Let's find the matrix CD minus DC. What do you think? You can ask yourself for a minute. What do you think the matrix CD minus DC, the final answer? You think it's zeros? Okay. No, the answer is no. So CD, just multiply in the same order, find each product, then subtract. So CD, 3 minus 1, 2, 3, and the D is 4, 1, 2 minus 3. Multiply row by column, row by column. So you get 10, 6, 14, row 2, column 1, and minus 7. Now multiply DC. We expect that these matrices, they are not the same. So I put here a rule. In general, AB not equal to BA. In matrices. Now, if these are real numbers, like 2 times 3 is equal to 3 times 2. So the product of real numbers is commutative. But the product of matrices is not commutative. So here, let's multiply now DC. Row 1, 4, 1, 3, 2. So that will be 12 to 14. I can write here 14. Then minus 4, 3, minus 1. Then 0, minus 11. When you subtract, you get minus 4, 7, 14, 4. That's the answer for the subtraction. It's not a difficult question. Question number 3 is nice. We have matrix A, matrix B. We need to find matrix X. So A is 1 minus 2, 0, 3. B minus 3, 4, 2, 1. Let's find the matrix X satisfying the equation 3x plus A squared equals B. You can pause a little, please, and try to check and find X maybe if you like. Then you can compare your answer and the method also. 3x plus A squared is equal to B. What do you think we can do here? Since I need X, X is a matrix, and for sure it will be 2 by 2, because we will add to A squared, which is 2 by 2, equals B 2 by 2. I can move A squared on the other side, it becomes minus A squared. But remember, I have to multiply A times A. Okay, so multiply A times A, then find B minus A squared. Let's continue. So A squared is 1 minus 2, 0, 3, 1 minus 2, 0, 3. Multiply row and column. See here, multiply row and column. 1, 1 minus 2, 0, so that's 1. 1 minus 2, minus 2, 3, 6, minus 6, minus 2, minus 8. So 1 minus 8, 0, 9. This is A squared only. So 3x I need. So B, take A squared, this one A squared, take it on the other side, minus A squared. Now subtract the matrices, because B is a matrix, A squared is the answer here, matrix. Then find the matrix X. That's the answer here. So we subtract now, minus 3, 4, that's B, 2, 1, minus 1 minus 8, 0, 9. Look at the answer here. This one, minus 4, 12, 2 minus 8. This one is 3x. We cannot divide matrices by numbers. So what do? We say multiply by 1/3, because the reciprocal of 3, here the reciprocal of 3 is 1/3. So 3x times 1/3 will be only x. Now multiply 1/3 on the other side, that will be scalar. So I put that in details here. 1/3 times minus 4, 1/3 times 12, 1/3 times 2, 1/3 times minus 8. So it simplifies to x. X will be minus 4 over 3, 4, 2 over 3 minus 8 over 3. That's question number 3. Question number 4, we have to find x and y. A little harder, but not complicated. We have matrix A 3, 0, minus 1, 4, matrix B 6, 1, 3, minus 2 given. Matrix E is given also, but in matrix E we have x minus y minus 3, 3x plus 3y, 43, and we need to find the values of x and y. If A minus B all squared is equal E minus 3I. We have seen I before, and I mentioned that here. So I is the 2 by 2 identity matrix. So A minus B squared. Now here, I think you need to pause a little here and check. Is A minus B squared is equal A squared minus B squared? Do you think? You can check it, you can check. Anything you can think of, you can check. But that will not be correct. A minus B squared is not equal to A squared minus B squared, because the product of matrices is not commutative. So I will find first here A minus B, just subtract A minus B. Then I have an answer inside here, 2 by 2. Then I square it. Square it means I multiply it by itself twice. Equals, I make an equation here, equals E, that's E is there up, minus 3I. I is 1, 0, 0, 1. Little long question, but not complicated. So I need subtract A minus B. So 3, 0, let me check the numbers here, 3, 0, minus 1, 4, and B is 6, 1, 3 minus 2. Subtract, just subtract normal, remember. 3 minus 6 is minus 3, 0 minus 1 is minus 1. Minus 1 minus 3 is minus 4. 4 minus 2 is 6. So this one here, minus 3 minus 1 minus 4, 6, is a minus b. Square it. I put here in yellow, a minus b squared. It means a minus b times a minus b. It is not a squared minus b squared. If you need the answer, I can tell you here, it will be a squared minus ab minus ba plus b squared. It's a little long, but it's better to subtract first, then square it. So I take here minus 3 minus 1 minus 4, 6, minus 3 minus 1 minus 4, 6, square it. Square it means multiply row by column. So minus 3 minus 3, 9, and then 4. So that's 13. You can continue. On the next slide, or it will take another slide also. A minus b squared is that one, e is there. So what do we need now? A minus b squared, I leave it. See, on this side, just leave it. On the right side, e, this is e, exactly as the given, minus 3i, 1001. So I include scalar here, minus 3 inside. Then I add. See, look here what will happen at the end. We have equal matrices. 13, this number, minus 3, minus 3, minus 12, this number, 40, 40. So they are equal. What do you think we can do? Remember, we need x and y. I cannot hear you, but you can try yourself. Just equate it. Equate it means take this number is equal to this number. Already minus 3 is equal to minus 3. Already 40 is equal to 40. So I take this number is equal to this number. So what do I get? Something nice. I get, if I make equal matrices here, it will be 13 equals x minus y minus 3, and minus 12 is equal to 3x plus 3y. So this is a linear system. You can use any method you like to solve it. There are many methods. Elimination, substitution, graphing, Gauss elimination, Gauss-Jordan, the inverse of matrices, Kramer's rule. So x minus y, if you rearrange it, x minus y is equal to 16. X plus y is equal to minus 4. Just simple, easy. I will use elimination method. So I will just add the system here, two equations. Y minus y, they will cancel out. 2x is equal to 12, x will be 6. Take this equation, first equation, x plus y is equal minus 4, second equation, y will be minus 10. So this is the value of x and y. Let's see the last question, which is not difficult, I think. We have x, 2 rows, so this is 2 by 3. Y, 3 rows, 2 columns. Z is 2 by 2. Let's find the matrix capital M, xy minus half z. It's nice to practice on this before you see the answer, if you like. So multiply x and y, you have to check, remember. And then minus half times the z, this is a scalar. Then you can find the whole answer for M. That might take 2 slides like this. Okay, first I have to check here, x and y. See, this one is 2 rows, 3 columns, 2 by 3. This is what I mean, must match. This is 3 rows, 2 columns. Always we go rows and columns. Always rows and columns. So these numbers match here. They must match. So the answer will be 2 by 2. Minus half, this is a scalar. You can include the minus half inside, change the signs, and put here plus. Or you can include the half, leave the minus outside, then you subtract. You get the same answer. You can try, please, now. So let's see now, capital M. Oh, I put here all the details for you. This is 2 rows here, 2 by 3, 3 by 2. So I will get in xy 32, 4 minus 1828. I put here all the numbers. See A11, A12, A21, A22. These are the details. And then I included the minus half already, all the minus half. I left with plus, easy to add. 80 times minus half is minus 40, minus 20 times minus half is 10, minus 56 times minus half, 28, 64 times minus half is minus 32. So when you add the matrices, now you add corresponding entries. Remember addition, this one, addition. So 32 you add minus 40. 4 you add to 10 is 14. This is capital M. Now, I will leave this for you. Nice to practice. Similar to the question we did. Practice number 1, given A and B. Find the matrix X. Satisfying this equation. Another one here, we have Y, 2 by 2, and capital T. K, there is a K inside. Minus 12, minus 16, 9. Find the value of this K if Y squared plus Y equals T plus 5I. You can make an equation. Nice. Question number 3. Also, we have a matrix 2 by 2 plus another matrix 2 by 2 is equal to this one, 1, 2, minus 5, minus 23. Find x squared plus y squared. The method is very clear here. You add, then you equate, make it equal. Find x, find y, square the x, square the y, add. The answers, usually only the answers in the last slide, practice number 1, 2, and 3. Thank you guys for watching and listening. I hope you get some help from this video. See you in another video, another topic. Thank you very much.